Here are the solutions to test number 2 for ECE 341 for summer 2023. The first problem, units PDFs. Suppose I have find a scalar to make this a valid PDF. What that means is if I currently look at the area, it's 1/2 plus 1. This area is 1.5. So to make this a valid PDF, I need to scale it so that the area is 1, multiplied by 2/3. The second part is find the Laplace transform. So here, the PDF look kind of like this, goes up and comes down. I don't know the Laplace transform of this. Take the derivative. The derivative of a step is the delta function. The height was 1. Derivative of a constant is 0. This has a slope of -1 in 2 seconds, minus 1/2, then goes back to 0. The delta function I like. This has Laplace transform of 1, delayed by 1 second, so this is e to the minus s times 1. Again, Laplace transform of delta is 1, delayed by 1 second. The step, I don't know what that is, so let's take the derivative again. The derivative of a negative step is a negative delta of 1/2. A plus 1/2 step has a derivative of a delta function, amplitude of plus 1/2. Again, I like delta functions. I know what their Laplace transform is. It's 1, delayed by 1.5 seconds. This one's a delta function. Actually, this one's minus 1/2. There's the amplitude. This has an amplitude of plus 1/2, delayed by 3.5 seconds. Now, to get here, I had to differentiate twice. To go back, I integrate twice. This I had to differentiate once. To go back, I integrate once. And then scale by 2/3 to make it a valid PDF. So here's your overall answer. Problem number 2. I have two uniform distributions. A goes between 0 and 2. B goes between 1 and 4. What is the PDF of A plus B? Well, in that case, I'll take the Laplace transform of A. This is a delta at 0, delayed by 2. The amplitude has to be 1/2 to make it a valid PDF. Area is 1. This amplitude is 1/3 to make the area 1. B has a delay of 1 second, delay of 4 seconds, 1/s per step. So there's Laplace transform of A and B. Laplace transform of X is A times B. Doing some algebra, the inverse Laplace transform of 1/s squared is t, u of t, delayed by 1 second, delayed by 3 seconds, delayed by 4 seconds, delayed by 6 seconds. So that is your answer. That is the PDF for x of t. Problem number 3. This looks at gamma CDFs. Let A and B be continuous exponential distributions. A has a mean of 3 seconds, so here's the PDF for A. There's the Laplace transform. B has a mean of 4 seconds. There's the PDF. There's the Laplace transform. Find the CDF of A plus B. The Laplace transform is just A times B. Integrate to get the CDF. So when I plug in numbers, here's y of s. Do partial fraction expansion. Take the inverse Laplace transform. And there's the CDF. As a check, the CDF should start from 0 and go to 1. If I plug in 0, I get 1 plus 3 minus 4 is 0. That checks out. Plug in t equals infinity, I get 1. That checks out. So there's the CDF. Problem number 4. This looks at the central limit theorem. If I cast the spell Insect Plague, it does 4 to 40 damage. If I'm a lowly thief with only 10 hit points, what's the chance I will survive an Insect Plague? What's the chance it'll do less than 10 damage? Well, with the normal approximation, I know the mean and variance of a 10-sided die. For 4 10-sided dice, the mean will scale. Mean goes up 4 times, becomes 22. The variance goes up 4 times, becomes 33. Take the square root, I get 5.7. So with the normal approximation, here's what the PDF looks like. It's a bell-shaped curve. The mean, the standard deviation is 5.7. I'm looking at the number 9.5. What's this area? To determine that, I determine the distance of 9.5 from 22 in terms of standard deviations. That's your z-score. The z-score is 2.17. From a normal table, I can convert that to a probability. That has a probability of 1.47%. So there's a 1.47% chance that I will survive an insect plague. Not asked for, but I can check in Monte Carlo. Cast 1 million insect plagues, count how many times the damage is less than 9.5, and that wound up being 1.2%. Normal approximation said 1.4%. It's right ballpark. Probably the right answer. Problem number 5. Suppose x is a uniform distribution that's continuous over the range of 1 to 10. In that case, x has a mean, has a variance. Let a be the sum of 3 x's, let b be the sum of 4 x's. What's the chance that a is going to beat b? Well, to do that, I find the mean and standard deviation of a and b, actually mean and variance. Here's the mean and variance of x. I have 3 x's for a, 4 x's for b. Now form a new variable, w. W is a minus b. The mean of w is mean of a minus mean of b, minus 5.5. The variance of w is the variances added. They don't subtract, they add. Kind of figure if they subtracted, I could have a negative variance. That's nonsense. They'll always add. Take the square root, it's 6.8. So here's the mean, minus 5.5. This right here is 0. I want to find out what is this area. To do that, I find the t-score, or z-score. The z-score is how far is 0 from the mean in terms of standard deviations. The z-score is 0.008. Using a normal table, convert that to a probability, it is 21%. So this area is 21%. 21% chance that A is going to beat B. There is a 79% chance B beats A, which kind of makes sense. B has 4 dice versus 3. Usually B is going to win. 4 dice will beat 3 dice. Again, not asked for, but I can check. If I run a Monte Carlo simulation, I've got numbers between 1 and 10, so the spread is 9 offset by 1. Add up 3 A's, 3 to get A, 3 to get B, or 4 to get B. Check, is A greater than B? Repeat 1 million times. A defeated B 21.58% of the time in this Monte Carlo run. My calculated odds were 21.18. Again, pretty consistent, so it's probably the right answer. And that is test number 2 for 341.